Section 7.8, Applications of Matrices and Determinants. These are the objectives. You can pause to read. I am moving on to the next slide. Excuse me. Vocabulary key concepts, determinant of a matrix, Kramer's rule, and cryptography. Next slide. Says use the determinant to find the area of the figure with the given vertices. Excuse me. So this is what you're going to do. You're going to use this formula. The area of a triangle given these three vertices is given by the formula you see there. Plus or minus 1/2 the determinant of a matrix. The matrix that is generated by these vertices. And this is the matrix that is generated by these matrices. It's actually a 3x3. And at the end, let me get a pen here. Notice I have -3, 2, 3. This is your first column. And then 5, 6, -5, second column. The last column is just ones. Why? Because it's just the formula. So we're going to find the determinant of this 3x3. The way that we're going to do this is we're going to do the following. The book shows you a different way. This is easier. Notice what I did. I wrote this first column right next to the third column, and then the second column right next to the, this new fourth column. Okay, so I rewrote the first and second column twice, and I wrote it in this manner. Now this is what I'm going to do to compute the determinant. I am going to compute the product of these three numbers, which gives me -18. Then the product of these next three numbers. Notice that these are diagonals. The product of this diagonal, the numbers that are in the following diagonal. So then 5 times 1 times 3 gives me 15. 1 times 2 times -5 gives me -10. And then at this point, now I'm going to go this way. I'm going to work with these diagonals, going up, 18, 15, 10. What am I going to do with these numbers? This is what I'm going to do. I'm going to take the sum of these three numbers, and then I'm going to subtract the difference of that two sums. And I get -56. Is this my answer? The answer, no, since I have plus or minus here. I use the plus whenever my answer is positive. I use the negative when my answer is a negative number. So in this case, since this is a negative number, I'm going to multiply by -1/2. And the answer is 28 square units. Let's move on to number 2. So now it says use the determinant to find the area of the figure with the given vertices. Now this is a rhombus. And remember, there's a relationship between a rhombus and a triangle. And a rhombus is twice the triangle. So this is what I'm going to do. I'm just going to use 3 vertices instead of all 4. Because I'm going to take the determinant of this triangle. And I'm not going to divide by half at the end. I'm just going to, whatever the determinant is, that's going to be my answer, given that it's positive. If it is not, then I multiply by a negative. So again, this is the way that I compute the determinant, on just like I show you number 1. Take the product of those 3, product of those 3, and so forth. Next product. And this is what you get. At this point, you're going to take the you're going to do the following with those sums. You're going to find the difference, and then you end up with -54. Is this going to be my answer of this, the area of this rhombus? Of course not. Of course not. Notice that you have a negative, so I am going to just multiply that by a negative, and I end up with 54 square units. Let's move on to the next slide. Here's number 3. It says use Kramer's rule to solve, if possible, the system of equations. It is possible, and this is how you're going to do this. Kramer's rule is basically on page 562. The way that I'm going to show you is a little bit different what the book shows you. Why? Because I think it's a little bit easier. But if you want to go to page 562 and try to decipher that, go for it. This is how you do it the way that I'm going to show you. Notice that this is what I have. I have an augmented matrix, but it's not this. Notice that this 4, 6, negative 3, 9 is this augmented matrix, which is the denominator that you see here. And these two lines here represent determinant. So I'm going to have to compute the determinant of this 2 by 2 matrix. How do I get this matrix? Since I'm looking for the x value, I'm not going to be using this x values. I am going to be moving this this column into this where the x's are. Notice that I have negative 10, 12, and then I bring down the y's, negative 3 and 9. Why do I do that? Because that's the formula. And then at this point, I define the determinant of the denominator, and you know how to do this. Multiply these, and take the difference of those numbers, and I end up with negative 54. I do the same thing for the determinant of this denominator, and I end up with 36 minus negative 18, which gives me positive 54. So what is x? It's basically excuse me, negative 54 divided by 54, which gives me negative 1. Now let's find the y value using Kramer's rule. So again, the determinant, this denominator is basically the same 2 by 2 matrix that I use to find x. The y value, the numerator of the y value is a little bit different. Now I keep the 4 and the 6. Now I'm not going to be using these numbers now. I am going to substitute this column where the y's are. Again, why do I do that? That is the formula. So I find the determinant of this numerator, determinant of the denominator. I already know that this is 54. I did that on x. So then, once I find the determinant, I get 48 minus 60, perform this operation, and I get 108. So y is 108 divided by 54, and this is my y value. So the solution to number 3 is negative 1, 2. And again, this is using Kramer's rule. Let's go to number 4. Again, using Kramer's rule, it is also possible here. So what I'm going to do is first, I'm going to work with, just to save some space, I'm going to work with the augmented matrix of the variables, and I'm going to find a determinant, which is what you see here. And I basically do what I showed you in number 1, and I end up with negative 82. So now let's find the x value. So the x value is going to be, again, this is the denominator, which I found already. How do I find what goes in the numerator of the x value? I'm not going to use these x values. I am going to substitute this column for the x values. That's why I have negative 2, 16, 4, and everything for the y's, bring it down. For the z's, bring it down. Find the determinant of this, and I get negative 4, 10. How do you find the determinant? Just look at number 1 and 2, and then at this point I simplify and I end up with 5. Then I go ahead and find y. How do I find, and again, this is the same for y, and this is also going to be the same for z. So how do I find this 3 by 3? Again, I don't use these y values. I substitute this column for the y's, and that's why you see 4, 2, 8, negative 2, 16, negative 2, 4, negative 2, 16, 4 here, and then 3, 5, negative 2. Find the determinant of this. I end up with negative 656. Excuse me. This is 8. Find z. By now you should see how I get this 3 by 3 matrix. Find the determinant of that. Like I said earlier, this is the same as the other two. And I get 164 for the numerator. Divide that by negative 82, and I end up with negative 164 divided by negative 82, and I get negative 2. So my solution is the following. And again, this is using Kramer's rule. Next slide. Here we go. This is different. This is write a cryptogram for the message using the encoding matrix. What's the encoding matrix? This right here, this 3 by 3. So then I'm gonna encode this message. Please send me money. This is what I'm going to do. I'm going to write this as I'm gonna write 3 columns. Why 3 columns? Remember this, the order is row times column. Why do I want 3 columns? Because then this is a 3 by 3 matrix, and I want these two to match. This and this have to match. Why? Because I'm going to be taking the product of these 2 matrices. So that's why you see this. This is a 3 by 3. Which lets me know that I need to write this as something by 3. The order has to be something by 3. If this was a 4 by 4, I need to write some number by 4. If this is a 2 by 2, then I need to write something by 2. So I know that this has to be 3, so then that's how I break up the letters that you see here. And for the spaces here, I am going to use this, which is going to represent 0. So 0, 0, 0, 0. Now, how do I get the following 7 by 3 matrix with numbers? I use the alphabet. P is the 16th letter on the alphabet, L is the 12th letter on the alphabet, and so forth. And again, I said that the space is going to be represented by 0. So now that I have this message written as a 7 by 3 matrix, now I'm going to encode this message by using the encoding matrix, which is this 3 by 3. How am I going to do that? I'm going to take the product. Once I take the product, this is what I get. Here you have an f squared. I don't give you the answer, but it's actually pretty straightforward. By the end of this video, you should know the answer to this f squared. Let's move on to number 6. Very similar to number 6. So here I give you this encoding matrix A, and this is the message you want to encode. You want to create a cryptogram. You want to make this message unreadable. So then I break it up the following way. Why do I have excuse me, why do I break it up the following way? Because notice that the order here is 3 by 3, and this number needs to match this number, so I know it has to be something by 3, so I break this up and it ends up being 5 by 3. The space here is 0. Since I have to have 5 rows, and at the end I don't have a letter, I need to write a space. So that's why I need to write A0. So then at this point, I just basically use the alphabet. Again, H is the 8th letter on the alphabet, A is the 1st letter on the alphabet. I'm going to multiply it by the encoding matrix, which was here, A. Once I do that, this is what I get. Now this message is what we call a cryptogram, and it can only be decoded if you know this. Let's move on to number 7. It says use A inverse to decode the cryptogram. So this is the message that is encrypted, or is encoded, unreadable. So then this is what I'm going to do. First, I'm going to find the inverse of A, and you should know how to do that. And then at this point, I'm going to rewrite this as a 9 by 2. Why? Because I'm going to multiply whatever this message is by something times 2. I mean, the order has to be something times 2. Why times 2? Because the order of this matrix is 2 times 2. And remember, these have to match in order for you to take the product. At this point, I multiply this, and it should give me the following. Then at this point, I can decode the message because now I use the alphabet. And it says to be or not to be. And again, zeros represent spaces. Let's move on to the last one. This is number 8. Very similar to number 7. So you give an A, and this is the message that is encoded. So first thing you want to do is you want to find the inverse. Once you do that, you want to break up this message and write it the following way. Why do I have this matrix? Because again, this is a 3 by 3 matrix. So then, since it's a 3 by 3, I want this number and this number to match. So I need 3 columns, and it turns out to be that I end up with 5 rows. Once I have that, I take the product, and this is what I get. Now what I need to do is basically match the letter with the number that you see here, and this is the message. And it's Nezahualcóyotl. This is the name of the elementary school that I went to in Mexico. Anyway, this concludes the video, and if you ask me in class, I can tell you why, if you understand, to a degree, you belong to a small percentage of the population that can accomplish something. And this concludes the video.